All right, in this lesson we're going to talk about the volume of prisms and pyramids. So let's talk about volume first and what is volume. And before we even get into that, let's talk a little bit about measurement and one-dimensional, two-dimensional, three-dimensional measurement, right? So when we talk about perimeter, right, the measurement generally around something per meter, right? Perimeter is a one-dimensional measurement. Right, so if you're measuring around a track or something like that, or let's just say even a box, right? You're just measuring the length. So let's just say this is 10 centimeters, right? Each side, we'll just say they're all the same, right? Obviously, it's 40 centimeters. It's a linear, one-dimensional measurement, right? One dimensional going this way, one dimension going this way. Now you could say, well, it's a two-dimensional shape, but we're only measuring in one dimension, right? That's what perimeter is. One dimension, right? We have one straight line here, or one line plus another line plus another line. So that's one dimensional. When we talk about area of a shape, area is two-dimensional, right? So back to the first one, right? So we would say the perimeter of this is 40, let's say it's centimeters, right? 40 centimeters. Now if we want to do that same shape, right? We want the area, everyone knows it's going to be length times width, right? And that would be 10 centimeters times 10 centimeters, which would give us 100 centimeters squared. So why is that squared? It's because how many centimeters, how many literal squares, when we say squared, we literally mean squares. How many squares that are 1 centimeter by 1 centimeter would it take to cover this entire shape? That's what it means. So we would break that up. And I know you guys have covered this extensively in elementary school, right? We could break this up into 100 of them, right? I know I'm doing a terrible job here, but you get the point, right? We could cut this up into 100 of those square centimeters. So when we say centimeters squared, we literally mean the shape of a square, right? So it is a square. How many of those? Now, what if you're covering something like a triangle or something like that, right? Or even, let's just say even like an abstract shape like this, right? And you're like, well, geez, we don't have a formula for that, but how many centimeters squares is it? And you might say, well, squares don't fit in this perfectly, right? I get to the edge here and then like, well, what about this little chunk here, right? Or what if I'm trying to wedge a square into here and it doesn't quite fit? So the idea is, yes, even though we might say centimeters squared, so let's just make up and say this is 50 centimeters squared. The idea is you could take pieces of that. You could chop up that square there, right? And chop it into pieces to fit different pieces here to fit in like a puzzle, like a mosaic, right? To cover that. So we even say squared even if the shape is not a square. So now the same idea with volume. Volume is a three-dimensional measurement, right? So how much does it take to fill something as volume? So let's take our square and make it into a cube, right? Let's say they're all 10 by 10 by 10. Every side is 10, right? 10 by 10 by 10, they're all 10. So volume is length times width times height. 10 times 10 is 100 times 10 is 1,000. So it'd be 1,000 centimeters cubed. And what that means, again, is how many cubes would it take to fit in this? Now, again, what if it's not a rectangle? So these are terrible cubes. How many of these that are 1 centimeter by 1 centimeter? So when we say cubed, we literally also mean how many cubes would it take? Now, what if you have a weird shape or like a cone or something? You go, well, I can't fit cubes in a cone. Oof, that's a terrible cone, right? There we go. I can't fit cubes in a cone. Well, what if the idea would be think, what if I melted them down, right? What if I melted all these cubes into a liquid and then filled it up? So we still say cubed even if the shape is not a cube because we literally mean how many cubes. So when we say squared, we literally mean how many squares of that size, 1 centimeter squared, right? And we say cubed, we mean how many of that cube. So if I'm saying centimeters cubed, it would take 1,000 cubes that were 1 centimeter by 1 centimeter by 1 centimeter. Literally how many cubes if we melted them down and poured it inside, okay? So that's what volume is. Volume is about capacity. You'll see questions like, how much does this hold? That's volume. What is the capacity? What does it take to fill something? How much fits inside? Those are volume questions, okay? So volume is a 3D measurement. And like we said, we use cubic measurements, cubed. Meters cubed, centimeters cubed, kilometers cubed, et cetera, et cetera. I don't know, I have meters cubed again, et cetera, though, right? The same thing, okay? So it's a three-dimensional measurement. All right, so let's go through these, and don't forget that formula sheet. You can use that same formula sheet I gave you in the previous lessons, okay? It's got on the back the volume formulas. Okay, so we're gonna go through a few different volume formulas here, and we're gonna start with the volume of prisms. What's a prism, okay? So I'm just gonna read this through here. A prism is a solid geometric figure whose two end faces are similar. So what does that mean? The end faces. So like think about a rectangular prism. This face here, this rectangle at the one end, is the same as the rectangle at the other end, okay? Same with a triangular prism. The triangle at one end is the same as the triangle at the other end. Same dimensions, right? So when we say similar, we mean it's the same dimensions. It's just located in a different spot, right? So that's what makes it a prism. We'll talk more about pyramids in a minute. So similar, equal, and parallel rectilinear figures. I know it's a hard word for me to get out. Whose sides are parallelograms. So in other words, long story short, the fancy way is just putting that together is these shapes at the ends match. We got a rectangle and a rectangle. That's why it's called a rectangular prism. A triangle at one end and a triangle at the other. They're parallel, they face each other, they're the same size. That's called a triangular prism. All right, now, as far as formulas go for these, you can look on your formula sheet. Let's start with the rectangular prism. Now, you already know what the formula is for that. Let me explain it first. You know what? I'll just peek at the formula sheet real close to remind you where you can find these things. So if you're at home and you're forgetting, just print out the formula sheet, and we're just going to go to the back of this formula sheet here. All right, here we go to the back of the formula sheet. And if you just scan down, now be careful. There are two types of formulas on the back. There are surface area formulas. We're not going to talk about surface area in these lessons. That'll be a separate lesson, okay? We're going to talk today about volume. So you want to pick the ones out of the volume column here, okay? Obviously, right? All right, so we're going to start with the rectangular prism. Now, notice how it gives you two formulas. It says volume equals the area of the base times the height, or volume equals length times width times height. These are the same formula. There aren't different formulas. It's the same formula. So let's explain, well, what does that mean? I'm going to go back to my diagram here. All right, to right here. All right, so when we're talking about the volume of a rectangular prism, think about a sheet of paper. That's probably the easiest way. We got a sheet of paper here, right? And even though it has a little tiny bit of depth, it's not very much, right? So we can kind of think about it as a two-dimensional shape. There is no, if you're wondering, a good question, in the real world, there is no such thing as a real two-dimensional or one-dimensional object, okay? It's a measurement we can take, but everything has 3 dimensions to it, right? So, but we can imagine a piece of paper. It's so thin, we don't have to worry about how deep it is, right? So what's the area of the base? The area of the base is a rectangle. So what is it going to be? Length times width, right? The length times the width. So I'm just using a little L there, right? So that's the area of the base. Now, imagine as you keep stacking up paper, right? You stack it up more and more and more and more, you keep stacking it up. It starts to get depth, right? So let's say we've stacked up a whole bunch of paper to here, right? Now we've got a whole pile of paper, right? And it has height to it, right? So the more you stack up, the higher it gets, and you fill that up, you fill that volume up. So that's all it is. It's length times width times height. So they write this formula out on your formula sheet so that you have an understanding, because it's important you understand where the formula comes from, because you get into some questions, you might need to think back to this. It's the area of the base times the height. And this is all formulas. This is how they're all basically found. They're all what is the area of the base times the height for volume. Okay, so the volume formula is just length times width times height. That's it. So this one's super easy. They're not all going to be like super easy like this. This is just our intro basic, right? So the volume is length times width times height. Doesn't really matter which are length, width, and height, because you can roll this thing around, look at it any way you want, right? Again, if you look at your formula sheet, it'll help you out, right? They have it labeled height, length, width, right? Length, width, height. There you go. All right, so what's it going to be? It's going to be, we'll say this is the length, this is the width, this is the height. They're all interchangeable in this case. It doesn't matter, because if you turn the box around, right, you still get the same 3 numbers. So we got 3 times 2 is 6. 6 times 4 is 24 meters cubed. We need to make sure we include those units. So meters cubed for all of our, or whatever units cubed. So meters, centimeters cubed, feet cubed, whatever. Now, the volume of a triangular prism, there's 2 ways of looking at it. It's got the same formula. Notice how it's written out. Look at right here, the same. Area of the base times height, area of the base times height. It's the same formula. In other words, you're all smart enough to figure out what this formula is on your own using that, right? You find the area of the base. Well, what's the area of the base? The base is a triangle, right? So how do you find the area of a triangle? Base times height divided by 2, right? What's the base of this triangle here? Let me just erase this so I can draw it a little better. So what's the base of the triangle, right? What's the height of the triangle, right? So base times height divided by 2, right? And then you times it by the height of this pyramid here. So what they like to use on your formula sheet, just jump into that. Here's the triangular prism. It's a little confusing, right? They've written it this way or this way. I like this one here the best. Now, instead of calling it base times height, because that's confusing, they're calling it base times length times height. The idea is, here's the base of your triangle, here's the height of your triangle, but they're going to call that L for length. And then imagine we have a bunch of papers and we just stack them up, right? We keep filling this thing up, filling it up till we fill it. What's the height? All right, so I like to use this one. Base times length times height divided by 2. All right, so all I got to do is identify the right numbers here. So what do we have? We have the base and the height of my triangle, which they're calling B on the formula sheet, and L. They're calling that length. Base times length. Now you divide that by 2. Now will give us the area of the triangle, right? And then we're going to times it by how tall this is. So it's laying on its side, right? So this is what they're calling the height. So I don't need this number here. That's kind of I don't want to say a trick, but it's just not necessary. Base times length. Sorry, that's a sloppy L. Times height divided by 2. Well, the base is 10. The length is 8.5. The height is 20. And divide that all by 2. So I'll just punch down my calculator, tell you what we get. And we get 850 meters cubed again. Now there's another way to look at the volume of a triangular prism. And that way is this. Think about what's the area, I'm just going to draw on here. Think about the area of a rectangle, right? Area of a rectangle, length times width, right? Well, what's the area of a triangle, right? The area of a triangle is just half. I could cut it this way or I could cut it this way, right? Let's say we made a triangle, right? The area of a triangle is always just half the area of a rectangle if you were to make that triangle into a rectangle. So the area of the triangle is just length times width divided by 2. So in other words, this formula to this formula, they're really the same formulas. This is length times width times height. They like to use base times length times height. I wish they just used width times length times height divided by 2. Notice how it's the same formula but divided by 2. They're using different letters, but it's the same thing. In other words, if we took this pyramid here, this triangular prism here, right? We could build a box around it. Think about this here. What if we went up like this and made a box, right? And a box at this end. What if we made it into a rectangular prism, right? And then we connected these dots and made a box about it. It literally, this triangle part here takes up 1/2, right, of the entire rectangular prism. So these formulas are essentially the same thing. I don't like that they use different letters. You could literally just make this length times width times height divided by 2 for this one here. All right, I think we've beaten that to death enough. You've done those shapes a lot in grade school, but I wanted to make sure you have a little more understanding of where they come from. I want to do one more shape in this video. All right, so now let's define what a pyramid is. So our formula sheet only has the volume of one pyramid, but they're all basically the exact same thing, okay? Now what is a pyramid? A pyramid is a solid geometric figure, again, it's a solid, whose one face is a polygon. So what do we mean by a polygon? A polygon is just a closed shape, right? Which means all the sides are connected. And it can have as many sides as it wants, right? So this one has a square on the bottom, right? There's a square, but it could be a rectangle, could be a triangle on the bottom. It could be, a pentagon, could be, 6 sides, 7 sides, 8 sides, right? We could make a pyramid. And all those points meet. This is a terrible job, but you get the point. There you go. They all meet at one point at the top, okay? So they're saying it, the proper common or fancy way to say it is, it's again, one end is a polygon whose sides and triangles that meet at a common vertex. So that means a common point. They all meet at one point, right? So you can have a pyramid with as many sides on the bottom as you want. And you, based on what I'm telling you right now, you don't need the formula sheet to find out any of them. We could add a whole bunch of sides at the bottom, you could figure it out. So how do you find the volume of this? It's the same as the other ones, right? You find the area of the base first. So how do you find the area of a square, right? Well, think about it again. We got this diagram over here, right? How do you find the area of the square? It's just length times width, right? Length times width. But if they're both the same, right, what they generally do is they just label them the same. So on your formula sheet, instead of calling them length and width, what they like to call it, and again, the point is that the letters they use don't really matter. It's identifying what the sides are. They like to call them B for base, okay? So it's base times base, right? That's how you'd find the area of the bottom, base times base. Well, what's base times base? Isn't it just base squared? So that's what this is, the area of the base, which would be base squared. So we're saying this is B for base, right? Times the height. So it's the same thing again as you start stacking them. But what happens? Imagine you stack up this piece of paper that starts out as a square, right? Each time you're stacking it, it's getting smaller and smaller and smaller the more and more paper you stack up, right? So it turns out that it takes 3 of these to fill a rectangular prism of the same size. So if we had a box that fit perfectly around this, okay, that fit perfect. In fact, maybe I'll draw this box around this guy here. If we had a box that fit, ooh, that's terrible. Oh man, here we go. A box that fit perfectly around this. It would take 3 of these pyramids to fill it. So imagine if we had the pyramid flipped upside down like a cup, right? We had it like this, and we could somehow fill it with water, right? We could fill this up with water and then pour it into this box. It actually takes 3 of them. So all this is 1/3 the volume of the box. So if you could find the volume of the box, length times width times height, and divide it by 3, that would be a pyramid that's inside of it. So it's a formula you already know, and that's what I'm trying to get. It seems like there's so many formulas to learn, but as you start learning a little more about this, you start realizing there's really only a couple formulas, and then the rest are all just a half of that or a third of that, right? Because remember, this one here, the triangular prism, was just half of this, right? It takes half to fill the triangular prism. The pyramid is just 1/3 of the box. So when I look at this, I don't even use my formula sheet. Again, this obviously comes with experience. All I do is I multiply the base, the length times the width of the base, times it by whatever the height is, and divide it by 3. All right, so that's our formula. And if I look at the formula sheet here, let's go have a quick look. Oops, I'm gonna go to that in a second. Here it is. Now, we wanna be over here. Again, there's the explanation of how it works. Area of the base times the height divided by 3. The one I like to use is this one right here. The area of the base, right, is the base squared times the height, there, divided by 3. So that's the formula I'm gonna use. So I'm gonna write that down here. Volume equals area of the base, base times base, base squared, times the height divided by 3. Now, before we go any further, there's something really important here we gotta discuss, okay? And then we'll be able to figure this out. When it comes to pyramids and cones, there's a super important feature that gets people messed up all the time. It's the slant height versus the true height. So let's start with a cone because it's easier to see in this diagram of a cone. When you are finding volume for cones or pyramids, we haven't talked about a cone yet, we'll get into that in the next lesson, but it's the same thing with both of them, so we'll cover it here. The height is the height going from the vertex at the top all the way down to the center of the bottom, okay? So same thing here, let me just highlight it, right? That's this guy right here, right? From the height to the center. The slant, so there's your true height. The slant is the length going down the side, like if you were to walk up the side, and that's a longer number. So same thing with a pyramid. If you go down the side, right, that would be the slant. Now, when you are doing volume, you need the true height. We need the height of these, okay? Not the slant. Sometimes the diagram gives us the slant. So how do we solve for the height? What we're gonna do is use Pythagorean theorem. So I got that written over here, okay? For volume, we always wanna use height. We're gonna talk a little more about surface area in a later video. That's when we use the slant, okay? So we're doing volume right now. Use the true height. If you're missing the height or the slant, you use Pythagorean theorem to find what you're missing. So what we do is, and that's what we're gonna do in this example here, right? We have a triangle, whether it's in a pyramid or whether it's in the cone, it's the same thing. So what we need to do is take, well, what's half the length of the bottom? Like if this was 10 across, for my triangle here, it would be half of that, right? It'd only be 5 across from there to there. So we set up a triangle like this here, where the base of this triangle is half the base of our overall shape, right? Just think about all the way across a cone too, right? The radius is halfway across, so we need that halfway distance, and the height, right? And the slant here, and we're gonna solve for what we need. So let's go back and check out that one right here. So what do we have? Let's erase all this extra junk and wrap this video up here, okay? All right, so we're back at this, and it says find the volume of this thing. This is where you need the true height. The height is up the middle. So I'm gonna try and draw that in here. Like to here, and then down the side is my slant, right? And here's my 90-degree angle. So let me just pull that out and draw kind of a sloppy triangle here next to it to show what I mean. Now they gave me the slant. That's 10. That's the slant going up the side. The slant would be like if you walked up the side of this pyramid. The height is what we need for this formula. And if you're not sure, look at your formula sheet diagram again, right? It says we need the height, H for height. Look at where the height is. They use S for slant. We don't want slant. They're using H for height. That's what we need, okay? So look at your formula sheet if you're ever unsure. But volume, we always need the height. And we need the length across the bottom. Well, 8 is all the way across the bottom, but our height comes down to the middle, halfway across, so that's 4. All right, so we're gonna have to do Pythagorean theorem here, right? C squared equals A squared plus B squared. All right, so let's plug in what we know. Which side's gonna be the C? The C is always the side across from the 90-degree angle. So C is gonna be 10. Now remember, A and B can be whatever. So I'm gonna make A 4 and B H, okay? So A is 4, B is the height that we're solving for. All right, so how are we gonna do this? Pythagorean theorem, square the 10, it's 100. Square the 4, it's 16. Can't square the H because we don't know what it is. We're gonna subtract 16 from both sides, right? So I got 84. And then remember we take the square root. So I'm just gonna flip this around here and make it the square root of 84. Now, you could figure out what that is, but what I do is I just wait till the end. It's a lot nicer to just leave this as that, right? So my height is 84. I guess I should include the units, centimeters. So if you're like, well, I want to punch that in my calculator and figure out the decimal, go for it. But what I do, and that's what you're going to find your teachers do as you move forward, we just leave it as the square root until we need to calculate it. So let's come back and figure out the volume of this guy now. All right, so volume, base squared times the height divided by 3. So the base is 8, right? That's our base of our entire pyramid. So 8 squared. The height is this number I just found. And see how easy, instead of having to write a bunch of decimal numbers down, I can just put this in, right? That's supposed to be a 4. It looks like a 9. There we go. Divided by 3. So what I'm going to do is, now I'm going to go do the square root of 84. Then I'm going to times it by 8 squared, and 8 squared is 64, right? So let's go, what's 64 times the square root of 84? And then divide that by 3. So I'll go punch that in my calculator, and then I'll write it down here. So again, square root the 84 now. All right, so it looks like when I do all that, I got, now we're going to write approximately, because we're going to round it. I have 195 it says 5.2. So let's round everything to 1 decimal, so 5 is the closest, right? And again, what are our units? Centimeters cubed. And there's our volume. So that's the big thing to look out for in this lesson. The first 2 shapes are super simple. It's when you see a cone or you see a pyramid, there's a very good chance you're going to have to use Pythagorean theorem. All right, so that's it for this lesson.